Hey, welcome to High School Math. My name is Rex. Today we're going to discuss business arithmetic, and that involves ratio, proportion, percentages, and their applications. It involves incremental sales, profit and loss, discount sales, and SI, which means simple interest. We're also going to discuss number bases and their operations. First of all, what is a ratio? A ratio is the relationship between two quantities or two numbers. So here's an example. I have three baskets, and each of these baskets contain fruits, and these fruits are apples and oranges. In each basket, there are two apples and three oranges. It means that the relationship between apples and oranges is 2:3, and this sign means the ratio sign. There are three ways to write this. This is the first method, this is the second method, and this is the third method. As you can see, 2:3 appeared as a fraction. And you might ask yourself, is a fraction also the same thing as a ratio? Well, yes, it is. This is because a fraction shows the relationship between the numerator, which in this case is 2, and the denominator, which is 3. This also means that for every basket of apples and oranges, there's going to be 2 apples and 3 oranges. What about proportion? Well, proportion is related to a ratio, but it deals with proportionalizing the ratio or equalizing it. So let's say I had 2 apples and 3 oranges before, right? And then I want to add more apples. So let's say the apples become 4 apples. How many oranges am I going to add to make this ratio equal? That is what it means to proportionalize ratios. Well, what you can simply do is cross multiply. If you cross multiply this number, which is 4 and 3, you're going to get 12. And the good thing about proportionalizing is that equal ratios must give you the same number. So what is 2 going to multiply to also give you 12 when it cross multiplies? Well, 12 divided by 2 is going to give you 6. So 6 is supposed to be here to make this ratios equal. If you cross multiply these numbers, you're also going to get 12. But here's a question. Does proportionalization only have to do with equal ratios that have to deal with bigger numbers? Well, no. It can deal with a bigger number and trying to proportionalize it with a smaller ratio. So let's say I had 12:24. And then I reduce these 12 apples to 1 apple. How many oranges am I going to have? Remember what I talked about cross multiplying? Here we have 1 and 24, which can be cross multiplied to give you 24. So what would 12 multiply to give you 24? Well, 24 divided by 12 is going to give you 2. So the number of oranges that are going to be in the basket are going to be 2. Alright, so what about percentages? Well, percentages are quantities as part, or fractional quantities as part of 100. And that is where the word percentage comes from. The word percentage means percent, and cent means 100. So it means per 100. It basically means a quantity out of 100. So I asked you, what is 20%? 20% is 20 out of 100. So if you had 100 apples and you ate 20 apples out of those 100 apples, then you've eaten 20% of the apples. So here's an example, all right? You have your phone charging, and your phone usually needs 5 bars to be full, and it's only 2 bars. How many percent is it? Well, it's expressing a fraction as a percentage. So first you write out the fraction, and if the fraction is not in its simplest form, you reduce it to its simplest form. But in this case, 2/5 or 2:5 is in its simplest form. So you multiply that by 100. And why are we multiplying by 100? Because we're trying to make it part of a whole or part of a percent to become a percentage, not just a fraction. So when we multiply 2 by 100, we're going to get 200. And then when we divide that by 5, we're going to get 40. So it means that your phone is 40% when it's only 2 bars full. So what about 3 bars? What would it be if it's 3 bars full? Well, it's going to be 60. Why is that? Because if we write 3/5 and multiply that by 100, 3 multiplied by 100 is going to give you 300. And 300 divided by 5 is going to give you 60. So 60% is how full your phone is. Okay, let's not talk about phones. What if you're eating apples and you had 50 apples and you ate 25 out of those apples? How many percent of the apples have you eaten? All right. You have to know that 25/50 is not in its simplest form. It means that it can still be reduced. So let's equalize this term, or let's proportionalize it to a lower term. So what can go in 25 that can also go in 50? Well, 5 can go in 25. 5 and 25 is going to give you 5, and 5 and 50 is going to give you 10. This is still not in its simplest form because something can go in 5 and still go in 10, and that is 5. 5 can go in 5 once, and 5 can go in 10 two times. So basically, we have reduced 25 over 50 to half. Now, if you ate 25 out of 50 apples, what percent is that going to be? Well, it's going to be half, which is just 25 over 50 reduced to its simplest term, and multiply that by 100 to make it a percentage. 100 times 1 is going to give you 100, and divide that by 2, it's going to give you 50. So you practically ate 50% of your apples. So we basically learned the ratio, proportion, and percentages, and even their applications. But here are a few more examples. So let's say for proportion, you want to share a quantity, because proportions can also be used in sharing quantities. And here's what I mean. If you want to share a stick 60 centimeters long among 3 people with a ratio 3, ratio 7, ratio 10. How are you going to share this stick? Let me write out the quantity, 60 centimeters. How are you going to share this? First of all, the formula is you add up the ratios, and then for each person or each person's ratio, you're going to write it as a fraction of the total ratio and multiply that by the total quantity you want to share. So we first add up the ratios, which is going to give us 20. So that's the total ratio. For this first person's ratio, which is 3, we're going to write that as a fraction of the total ratio, which is 20. Multiply that by the total quantity you want to share, which is 60. And when you cancel out these zeros, you're left with 3 multiplied by 6, which is 18, and then divide that by 2, that's going to give you 9 centimeters. It means that the ratio isn't necessarily how you're going to share the stick. It means that if you had 60 centimeters, you're not going to give one person 3 centimeters and give the second person 7 centimeters and give another person 10 centimeters. Because first of all, that wouldn't even add up. Remember, you're trying to share a quantity equally according to their ratios. So the ratio isn't exactly the quantity, it's just a ratio of how to share the quantity. So the person with ratio 3 is going to get 9 centimeters of the stick. So let me write that down. Next is the person with ratio 7. Write that as let me clean this calculation actually so I can have some space to show you. All right, write 7 as a fraction of the total ratio. Multiply that by 60. The 0 here cancels the 0 here, and we're left with 7 times 6, which is 42. Divide that by 2, and we're going to get 21. So it means this person with the ratio 7 was going to get 21 centimeters. And what about the last person? Well, the last person has a ratio of 10. Right, 10 as a fraction of 20. Multiply that by 60. The 0 here cancels the 0 here, so it's practically half. And half of 60 is 30. So we have 30 centimeters. It means that the ratio of these people's, the sharing of this thing is going to be, oh wait, let me write it down, sorry. It's supposed to be 30. As you can see, this is also an equal ratio because 10 had to multiply 3 to give you 30, 7 had to multiply 3 to give you 21, and 3 had to multiply 9 to give you, 3 had to multiply 3 to give you 9. This is another use of proportion. Now let's discuss incremental sales. Let's say you run a lemonade stand and you normally sell 20 cups per day and you earn a steady amount of dollars. And let's say that one day you decide to give people cookies as you give them lemonade. Of course, the cookies will inspire people to buy more of your lemonade. So what is an incremental sale? Well, incremental sale is an increase in profit or an increase in money gain because you added a bonus to your sales. So your bonus in this case is the cookies. Or let's say, for instance, you added a new flavor apart from regular lemonade, like strawberry. That would stimulate people to buy more from you. Let's say you always sell 20 cups per day. And when you added cookies, which is the bonus, you started selling 50 cups per day. What is the incremental sale? Well, the incremental sale is the difference in the old price and the new price, which is 30 cups. That is incremental sale. What if you want to find out the percentage of the incremental sale? Remember, to make a fraction a percentage, you have to multiply that by 100. So to find out the percentage of incremental sales, you have to find the difference between the old sale and the new sale. The old sale was 20 and the new sale is 50. So it's 50 minus 20. And then you're going to divide that by the old sale, which was 20. And to make this a percentage, you have to multiply by 100. And when you subtract 50 and 20, you're going to get 30. And 30 over 20 is going to be 3 over 2 in simple terms. Multiply that by 100, you're going to get 3 times 100, which is 300, and divided by 2, which is going to give you 150. Next, we're going to describe profit and loss. What is profit and what is loss? Well, profit is the difference between how much you bought something and how much you sold that thing. And loss is actually the same thing. The only difference between profit and loss is that how much you sold that object should be more than how much you bought the object. And loss is that the selling price or how much you sold the object is less than how much you bought the object. So here's an example. Let's say you bought a wristwatch for $150. Okay, and then you sold that wristwatch for $200. What is the profit? Well, this is a profit because how much you sold it, or the selling price, SP, is greater than that of the cost price, or how much you bought it, which is CP. So the difference between these two numbers is 200 minus $150, which would give us $50. So $50 is your profit. It's like the extra money gained after selling an object. So what about loss? Let's say you bought that watch, or you bought another watch for $150, and then you sold that watch for, let's say, $140. And so $140 is how much you sold the watch, which is the SP, and then the cost price is $150, which is how much you bought the watch. So the loss, because in this case the cost price is more than the selling price, the loss would be $150 minus $140, which would give us $10. All right, and the lesser the difference of the numbers, the less the loss. So because 140 is a very close number to 150, the loss was just $10, which isn't much. But let's say that the cost price or how much you bought the watch was $1,000 and you only sold it for $140. The loss would be really, really high. So what about when we're trying to find profit and loss percent? Remember, when we're trying to find the percent of a fraction, we basically multiply by 100. So here's the formula. Let's say I bought that watch. Let's use that watch example. $150 is how much we bought the watch, and then we sold that watch for $200. What is the profit percent? Well, the profit percent, remember that profit is the selling price minus the cost price. So the formula is the selling price minus the cost price. Remember that this is profit. And then you divide that by the cost price, which was the original amount. And to find it as a percentage, you multiply it by 100. So let's impute our values. The value of the selling price is 200. The value of the cost price is 150. Down here, the cost price is also 150, and then when you multiply that by 100. So 200 minus 150 is going to give you $50. $50 over $150, and then you multiply that by 100. So I just like to simplify this. So I'll simplify this fraction. So simplify this fraction, I'll reduce it by its lowest term. And what's the highest number that can go in 50 and 150? Well, the highest number I can think of that can go in 50 and 150 is 5, though I don't think it's the highest number. So 5 can go in 50 10 times, and 5 can go in 150 30 times. As you can see, there's still a number that can go in this, so that's why 5 wasn't actually the highest number. So 10 can also go in this fraction. 10 can go in 10 once, and 10 can go in 30 3 times. So this is 1 over 3. So we'll write 1 over 3, which is the simplified fraction of this, multiply that by 100. So 100 multiplied by 1 is 100, and 100 divided by 3 is, let me calculate that, 100 divided by 3. 3 divided by 3 in 10 is going to give you 3 remainder 1, so 3 times 3 is 9, and 10 minus 9 is 1. Bring down the 0. And so bring down the 0. 3 can go in 10 3 times again. 3 times 3 is 9. Bring down that 0, and then we have 0. We have 1. We have 1. So if we keep on dividing, we're actually going to get 33.3333 to infinity, so I'll just say it's 33%. This is the profit percent. And loss percent is the exact same thing, only that the cost price and selling price would change. So let me clean this off. It will no longer be selling price minus cost price divided by the cost price multiplied by 100, but it's now going to be cost price minus selling price divided by the cost price multiplied by 100. This is how to find loss percent. What does it mean for an object to have a discount?
Well, it practically means that you're going to be saving a certain amount of money instead of paying the full amount of money. So let's say that a ball costs $100, all right, which is actually kind of impractical because I don't know any regular beach ball or basketball that costs $100. But let's say a ball costs $100, and when they say like there's a 20% discount on the ball, what does it mean? Wait, let me write this down. It means that instead of paying 100%, which means you pay 100% amount of the money, which is $100, you're going to be saving 20% of the money. So let's find 20% out of 100. Well, 20% out of 100 multiplied by 100 in a percentage is a 0 here cancels the 0 here, and this other 0 cancels this 0. So we're left with 2 multiplied by 10, and 2 multiplied by 10. Yeah, that will give you 20. So you're actually saving $20. Where did I get the fraction from? Well, you have to remember that your discount is 20%. You're finding 20% out of the $100. So you're not finding out, you're not changing this to a percentage because it's already in a percent. Remember, I said you multiply by 100 to change a fraction into a percentage. But this is already a percentage. So the 100 I was multiplying is changing it from percentage into the amount of money you have. So you had 20%, which is 20 out of 100, multiplied by the number of money or the number of dollars you have, which is $100. The 0 here canceled out 0 here, so we're left with 2 over 10, which can be represented as 1 over 5. Because if I simplify it, we're going to divide 2 by itself to give us 1, and 2 by 10 to give us 5. So let me clean this off and write it as its simplest term, which is 1 over 5. If we multiply 1 by 100, it's going to give us 100, and then divide that by 5 is going to give us 20. So you're actually going to pay $20 instead of having to pay $100. That is discount. And what about simple interest? Well, simple interest practically means the formula for simple interest is the principal, which is the amount of money you pay, multiplied by the rate, multiplied by the time, and divide that by 100. So what is the simplest definition of simple interest? Well, if you ask for a loan from someone, which is practically borrowing or somebody lending you money, you have to pay back. And sometimes you don't just pay back the exact amount. The person will ask for a simple interest, which is a little higher than the original amount. So let's say you borrowed $1,000 from the bank, all right? And you borrowed $1,000 from the bank, you have to pay back. And they ask you, instead of paying back the exact amount, which is $100, you're going to make it a simple interest. It means you're going to add a little more money. So it means that if you borrowed $1,000, you're going to pay back that $1,000 at a certain rate, which will, let's say, 4%, for 2 years. So this is what you're going to do. So if you borrowed $1,000 from the bank will tell you to pay back that $1,000 not just once, but 2 times. You're going to pay 4% 2 times because it's 2 years. So each year you pay 4% $1,000. So this is the principal, this is the rate, and this is the time. You multiply all these values and divide it by 100. So let's do that. The principal is 1,000. 1,000 multiplied by 4 is 4,000, and 4,000 multiplied by 2 is 8,000. So 8,000, and then we divide that by 100. So when we divide and cancel out these zeros, we're left with 80. So this 80, let me clean this off, is the simple interest. So remember that simple interest is gotten from the principal, which was 1,000, multiplied by the rate, which was 4%, multiplied by 2 years. Let me put the multiplication signs there. And then when we multiplied all the values, we got 8,000 and divided that by 100 to give us $80. This is the simple interest. What about number bases? Well, we generally use one basic system called the decimal system, and the decimal system is base 10. Base 10 generally involves 10 numbers. Let me write them down. 0, 1, 2, 3, 4, 5, 6, 7, 8, and 9. If you've ever looked at the keypad of a phone, it only has 0 to 9, which are 10 digits. That's our decimal system. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. But there are also other systems like octal system, which is base 8, or hexadecimal system, which is base 16, and the binary system, which is base 2. So we'll just be calling them by their different bases. Base 2 uses only 2 numbers, 0 and 1. So that's why binary system is only 0 and 1. You can make up a totally different binary system, and when you change that to decimal, you actually have a sensible number. So I can call something like 0112 sorry, 01101110001111001. And if I write this down and you convert it to a decimal system, it's actually going to make sense. Now let's learn the trick. How can you convert from one decimal system, or sorry, from one base system to another? Let's learn about converting from the binary system to the decimal system. So let's say I have a binary number 101101. How do we convert this to decimal? You must always write the base it is in as a subscript. If it's in base 2, you write 2 as a subscript, so people will know that 101101 is a number, because you can write this and somebody would think it is 101,101 in base 10. So you have to specify the base system it is in. So how do we convert this to base 10? First of all, you have to label at the top from 0 to wherever the number stops. So we're going to name this 0, this is going to be 1, this is going to be 2, this is going to be 3, 4, and then 5. So what you're basically going to do is you're going to multiply this number, the digits of the binary number, multiply it by the base it is in, and then the exponent of the base is going to be the numbers at the top of these digits. So let me write them down so you can see. So the first one is 1. 1 would multiply 2, and the exponent, or the power of 2, is going to be the number on top of 1, which is 5. So this is 1 multiplied by 2 raised to the power of 5. We're going to add to 0 multiplied by 2 raised to the power of 4. Next is adding to 1 multiplied by 2 raised to the power of 3. We're going to add that to 1 times 0. Oh, sorry, not 1. Not 0, sorry. 1 times 2 raised to the power of 2 plus 0 multiplied by 2 raised to the power of 1. And lastly, add it to 1 multiplied by 2 raised to the power of 0. Alright, so let's check this out. 1, 0, 1, 1, 0, 1. So it's complete. Now we just need to find out these values. 2 raised to the power of 5 is 2 multiplying itself 5 times. So 2 multiplied by 2 is 4. Well, let me write that down. 2 raised to the power of 5 is going to be equal to 2 multiplying itself 5 times, which is 2 times 2 times 2 times 2, 2 times 2 times 2 times 2 times 2. Okay, so 2 times 2 is 4, and then 2 times 2 is 4, and then multiply by 2. So 2 times 2, 4 times 4 is 16, and then 16 times 2 is 32. It means 2 raised to the power, sorry, I didn't write the 2. It means that 2 raised to the power of 5 is 32. So 1 multiplied by 2 raised to the power of 5 is 1 times 32, which will give us 32. 0 multiplied by 2 raised to the power of 4. Well, 2 raised to the power of 4 is 2 multiplying itself 4 times. 2 times 2 times 2 times 2. This is basically saying 4 times 4, which is going to give us 16. But 0 is multiplying 16, and any number multiplied by 0 is going to give you 0. So the 16 was practically useless. And then 2 raised to the power of 3 is 2 multiplying itself 3 times. 2 times 2 is 4, and 4 times the third 2 is going to give us 8. Since 1 is multiplying 8, the answer is going to be 8. Here, 2 raised to the power of 2, or 2 squared, is 4. Remember, 2 squared, or 2 raised to the power of 2, is 2 multiplying itself 2 times. So 2 times 2 is 4. And since 1 is multiplying 4, it's going to give us 4. 0 is multiplying 2 raised to the power of 1. 2 raised to the power of 1 is just 2, because 2 isn't multiplying any number of itself, just 2. But since 0 is multiplying 2, it's going to give us 0. What about this last one? What do you think 2 raised to the power of 0 is? Well, you might think that 2 raised to the power of 0 is 0. Well, the law of indices state that any number raised to the power of 0 is 1. So you can have 1 million raised to the power of 0, and the answer is just 1. So here we have 2 raised to the power of 0, and 2 raised to the power of 0 is 1. Since 1 is multiplying 1, we're going to get 1. If we add all these values, we're going to get the number in the decimal system. 32 plus 8 is going to give us 40. Because 32 plus 0 is 32, then 32 plus 8, like I said, is 40. 40 plus 4 is 44. 44 plus 0 is 44, and 44 plus 1 is 45. So this is 45 in the decimal system. So 101101 was actually making sense in the decimal system. But what about changing from the decimal system to the binary system or the base 2 system? So let me think of a number. Let's say we have 73. And we want to change 73 as a decimal number into a binary number. What we're going to do is that we're going to keep dividing this number by 2. And if it's going to give us a remainder, it's the remainders that are going to be the binary numbers. And you will notice that as we're dividing these numbers, the remainders are either going to be 1 or 0. So let's start. We're going to draw this line, and then we're going to start dividing. 2 can go in 73 36 times with a remainder of 1. So it's 36, remainder 1. We've gotten our first number, 1. Number 2, we're going to divide 36 by 2 again. 2 can go in 36 18 times. So it's 18 times with no remainder. 2 can go in 18 9 times with no remainder. 2 can go in 9 3 times. 2 can go in 9 4 times, but with a remainder of 1. 2 can go in 4 2 times with a remainder of 0. 2 can go in 2 once with a remainder of 0. Now, what do we do now? Because we've already reached 1. Well, you have to divide that 1 by 2, so it can give us a 0. It can give us a 1, because most binary numbers start with 1. So 2 is going to divide 1 to give us 0, remainder 1. You must always do this last step. Whenever the number you're dividing has reached 1, you still have to divide the number you're trying to change to the system by that 1. You mustn't stop there. You must end at 0. All right, so 2 can go in 1 0 times the remainder of 1. Now, you might think we've gotten our binary system, and we're not going to deal with these numbers. We're going to deal with the remainders. It's the remainders that are going to be the binary numbers. And the binary numbers aren't going to be 1 0 0 1 0 0 1. It's actually going to go upward, not downward. You're not counting downward 1 0 0 1 0 0 1. You're going to go upward. So it's going to be 1 0 0 1 0 0 1, which is actually the same thing. But just keep that in mind. You must always go from, if you're counting the binary numbers, you go from downward to upward. So 73 in base 10 is going to be 1 0 0 1 0 0 1. But it's not only that binary systems or decimal systems that exist. Like I said, there's even base 3, base 4, base 5, base 6, base 7, and so much more bases. So how do we convert from one base to another? Well, if you want to convert from one base to another, you first have to convert that original base to base 10, and then convert that from base 10 to the next base. Remember, if you want to convert a number from a number base to base 10, you have to follow that method that involved using exponents and indices. And then if you want to convert a number from base 10 to the base system, you just have to divide that number that is in base 10, and whatever remainders it's giving you, it's going to be the number system. Remember, the number you're using to divide that number is going to be the binary system, the base system. So let's not use base 2, let's use base 6. Okay, what if I want to convert base 6 to base 3? So let's say I have 56 in base 6. Remember that a base system or a base 6 has 6 numbers, which are namely 0, 1, 2, 3, 4, 5. So 6 isn't included. So 56 can't work. I'll say 54. 54 with base 6. As you can see, it only has 1, 2, 3, 4, 5, 6 numbers. So you can scramble these numbers however you want. But I wanted to choose 54 in base 6. So let's say we want to convert 54 to base 3. You don't just convert directly. You change it to base 10, and then from base 10 to base 3. So let's change this to base 10. We use the same method we use for binary numbers. So this is going to be 0, and this is going to be 1. 5 is going to multiply 6, and the index for 6, or the power for 6, is going to be 1. We're going to add that to 4 multiplied by 6, and the power for 6 is going to be 0. Now, 6 raised to the power of 1 is just 1 6, so it's not really multiplying anything. 5 times 6 is going to give you 30. We're going to add that to 6 raised to the power of 0 is, if you remember, I told you that any number with a power of 0 is going to give you 1. So 6 raised to the power of 0 is just going to give us 1. And 4 times 1 is going to give us 4. So if we add 30 and 4 together, we're going to get 34 in base 10. So 54 is 54 in base 6, and then in base 10, it's 34. Now, we said we were going to convert this to base 3. And now to convert this to base 3, let me write down what we got. We got 34 in base 10. Now to convert this to base 3, we have to divide 34 constantly until it reaches 0. And the number we're going to use to divide 34 is 3, since we're changing to base 3. All right, so let's say I have 3 here, and then I have 34. 3 can go in 34 11 times with a remainder of 1, because 3 times 11 is 33, and 33 plus 1 is 34. 3 can go in 11 3 times with a remainder of 2, because 3 times 3 is 9, and 9 plus 2 is 11. Now 3 can go in itself once with a remainder of 0, right? Because 3 times 1 is 3, and 3 plus 0 is 3. But remember, we don't just stop at 1. We must reduce this one to a 0. So it's going to be 3 divided by 1 to give us 0, remainder 1. And so we're left with, remember, we don't say 1, 2, 0, 1. We say 1, 0, 2, 1. We're counting upward. So we're going to have 1, 0, 2, 1 in base 3. If you notice, it only had 3 digits, 0, 1, and 2. And these are 3 numbers in the base 3 system. Complete, 0, 1, and 2. What about numbers in the same base system? Or what about basic operations with base numbers, such as base 3, base 2, base 5, and such as addition, subtraction, multiplication, and division? Well, I'm going to explain to you how we add numbers in the decimal system. We all know that we add them normally, but I'm going to go to the details so we can explain how to solve other bases. So let's say we have 35 in base 10 and 42 in base 10. I'll write just one base 10 because we know that they're both in base 10. If they were in different bases, you have to write the base for this other number. So 5 plus 2 is 7, and 3 plus 4 is 7. This is the exact same thing for other bases. If the number is below the base system it is in, you can just write it normally. For instance, if I was adding, let's say, 0, 1, and 1, 2, oh, sorry, not 1, 2, let me say 1, 1 in base 3, and they're both in base 3, I just need to say 1 plus 1 is 2, and 0 plus 1 is 1 in base 3. You don't have to do anything. But let's say, for instance, that this decimal number wasn't 42 or something higher, that you have to carry the number. Let's say maybe 49, base 10. So what is 5 plus 9? 5 plus 9 is 14. So we just say 4 and we carry the 1 up here. And then 3 plus 4 is 7, plus 1 is going to give us 8. So this is 84 in base 10. But what actually happened? How did we carry up that 1? Well, what we did is that when we said 5 plus 9 is 14, because it's in base 10, we have to say how many times can 10 go in 14? 10 can go in 14 once with a remainder of 4. Now, we wrote 4 here, and then we took the remainder up here. Or sorry, we wrote the remainder down here and took the whole number up here. You see why we always carry numbers in base 10? And then when we said 3 plus 4, 7, and 7 plus 1, 8. 8 is less than base 10, so we just wrote it down. So let me explain this with other bases. Let's say we're talking about base 2, and I have 1, 1, 1 plus 1, 0, 1 in base 2, and they're both in base 2. So 1 plus 1 is 2, and this is in base 2. So 2, how many times can 2 go in 2? 2 can go in itself once with a remainder of 0. So this is 1, remainder 0. Remember, the remainder is what we put down here, and the whole number is what we carry. Since the remainder was 0, we just write 0 down here. There is no other thing. Remember, the whole number is 0 because it can go in itself once remainder 0. So we take the whole number here. Next, we say 1 plus 1, which would give us 2, and 2 plus 0 would give us 2, right? How many times can 2 go in itself? 2 can go in itself once with a remainder of 0. The remainder goes down here, and we take the whole number up here. Well, 1 plus 1 plus 1 is 3. And how many times can 2 go in 3? 2 can go in 3 once with a remainder of 1. So we're going to write that here. Remember, there's no number for us to carry the whole number to, so we just write them down. So this is how we add it in base 2, 1, 1, 0, 0. Let me just add one more in one more base system. just to keep this clear. Let's see, we're adding in base 6. So we have 54 in base 6 plus, let's say, 32 in base 6. 4 plus 2 is 6. And 6 can go in itself once with a remainder of 0. So this is 0, and we carry the whole number up here. 5 plus 3 is 8, and 8 plus 1 is 9. How many times can 6 go in 9? 6 can go in 9 once with a remainder of 3. So we just write it down here. If you notice, we only got 130, and 130 is within the range of numbers for the base 6 system. And subtraction follows the exact same thing. Remember, okay, let me give an example. Let's say you're saying 54 minus 49. We all know that 4 can't go in 9, or 4 can't subtract 9, so we had to borrow from 5 to give us 4. We had to borrow from 5, and we had 4. So the one we borrowed from 5, we took it here, and we had 14. So 14 minus 9 is 6, and 4 minus 4 is 0. Why does it happen this way? Well, what we actually did is that when we took out 4, or when we took out 1 from the 5, and it gave us 4 up here, this one became a 10. Let me explain. Let me write it wider so you can see it. So this is 54, and this is 49, and they're both in base 10. Now we're going to subtract. 4 cannot subtract 9, so we borrow from 5, and we put 1 here, while the remainder is going to give us 4. Well, I don't need to write that down. You already know that the remainder is going to be 4. So 14 can subtract 9 6 times, and 4 minus itself is going to give us 0. So we're left with just 6 in base 10. But what really happened? Well, when we took 1 from here, that's from the 5, and it remained 4, the 1 became a 10 because we're using the base 10 system. So we added 10 to 4 to give us 14. That's where this 14 came from, and then 14 minus 9 gave us 6. Then we had 4 minus 4 to give us 0. So let's use another base system. Let's say we had 1110 minus 0110, or 0111. So we can be able to use that example. And they're all in base 2. 0 cannot subtract 1, so we borrow from this other one, and we're left with 0. When we take out, we're not going to take out 1. Based on the system we're using, which is base 2, we're going to take out 2 from 1. So 2 is going to come here and add this 0. 2 plus 0 is 2. So I can clean off this 0, so there can be space for me to write this 2. And it will be 2 minus 1. 2 minus 1 is going to give us 1. So I write that down. 0 cannot subtract 1, so we borrow from this other one, and we're going to take out 2. 2 is going to add 0 to give us 2. 2 minus 1 is going to give us 1. We're left with 0 here, again, just like this other scenario, and we're obviously going to get 1 with the same process. And lastly, here is going to be 0, because we took from here to add here. 0 minus 0 is going to give us 0. So 1111, which became a 2. Sorry, let me clean that up. 1111 minus 0111 would give us 0111. What about multiplication of number bases? Well, multiplication of number bases still follows the exact same process. So let's say I was multiplying 34 multiplied by 5 in the base 6 system. All right? 4 times 5 is going to give you 20. How many times can 6 go in 20? 6 can go in 20 3 times with the remainder of 2. So that's 2 will be down here, while 3 will be the remainder. 3 times 5 is going to give us 15. And 15 plus 3 is going to give us 18. How many times can 6 go in 18? 6 can go in 18 3 whole times without the remainder. So it's going to give us 3, remainder 0. Why didn't I just write 3 and not 0? Remember, both the whole number and the remainder are important. So this 0 must also stand out. So 34 multiplied by 5 is going to give us 302 in the base 6 system. And when it comes to dividing bases, the method is actually a bit different. When you want to divide a base, whether it's the same bases or different bases, you first convert them to base 10 before you divide. So I'll just give you one example. So I have 2 bases here, and I want to divide these bases. So when I want to divide these bases, I don't just divide them with regular division. I'm going to convert them to base 10, then I'll divide them in base 10, and then convert them back to base 2. So if I convert this to base 10, let's solve it here. 0, 1, 0, 1, 0, 1, 0. And this is going to be in base 2, 0, 1, 2, 3. 1 is going to multiply 2 raised to the power of 3. Let me clean this off. Add that to 0 is going to multiply 2 raised to the power of 2. And then add this to 1 multiplying 2 raised to the power of 1. And adding that to 0 multiplying 2 raised to the power of 0. 2 raised to the power of 3 is 8. 1 times 8 is 8. 2 raised to the power of 2 is 4. 0 times 4 is 0. 2 raised to the power of 1 is 2. 1 times 2 is 2. 2 raised to the power of 0 is 1. And 0 times 1 is 1. Since these zeros don't actually matter, 8 plus 0 is 8. 8 plus 2 is 10. And 10 plus 0 is 0. 10 plus 0 is 10. So 1, 0, 1, 0 in base 10 is 10. What about converting 1, 0, 1 into a binary system? Into base 10 system. It's already in binary system. So 0, 1, and 2. 1 multiplies 2 raised to the power of 2. Add that to 0 multiplying 2 raised to the power of 1. And add that to 1 multiplying 2 raised to the power of 0. 1 times 2 raised to the power of 2. 2 raised to the power of 2 is 4. And 1 times 4 is 4. 2 raised to the power of 1 is 2. 0 times 1 2 raised to the power of 1 is 2. 0 times 2 is 0. And then 2 raised to the power of 0 is 1. 1 times 1 is 1. 4 plus 0 is 4. 4 plus 1 is 5. Now we've converted this to a base 10 system, and then we can divide. Since it was 1, 0, 1, 0 divided by 1, 0, 1, it's 10 divided by 5, which is going to give us 2 in base 10 system. So to convert this back to binary system, we use that method. 2 in 2, 1 remainder 0, and 2 in 1, 0 remainder 1. We count this upward, and it's 10 in base 2. Was that clear? I just divided 2 by 2, and it gave us 1 remainder 0, and then I had to divide this 1 because we have to end up with a 0, not a 1. So 2 divided by 1 would give us 0 with the remainder of 1. And we counted it upward, we got 10 in base 2. You can also use this when you're dividing different bases. For instance, if you were dividing a number in base 2 and a number in base 6, you have to convert both of them to base 10 and then convert them to the desired base. Question time. Number 1. Give me the equivalent ratios of 1:2, at least 2 equivalent ratios, apart from 2:4 and 3:6. At least some 2 equivalent higher ratios. Remember, when you give a higher ratio, you're actually proportionalizing the ratios. And number 2, okay, this is number 1. Number 2, if I had $100 and I wanted to share it among 3 people in the ratio 2:8:10, what would I give each person? Or how much money would I give each person? Let me know in the comments. If you enjoyed this class, please like, subscribe, and share with at least 3 people who you know don't have access to basic education or who is bold enough to explore homeschool. And I'll see you in the next class.